Today on the Perception in Action News, an analysis of ringside feedback in boxing, and how does our ability to localize objects depend on our inherent and momentary action capabilities. So it's time for a call to action. Hi everyone, this is Rob Gray from ASU and PerceptionAction.com. Welcome to the Perception in Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. Before I get into the articles today, I wanted to mention a conference that I'll be speaking at this November in San Francisco. It's called the Sports Biometrics Conference, with the tagline, Where Data Science Meets Sports Science. It's shaping up to be a really interesting conference, with scheduled talks on topics including big data in sports, avoiding injuries with biometrics, sleep and fatigue management, biomarker-based assessment of concussions, athletic intelligence, and a few case studies of use of biometrics in specific sports. My session is called Attaining Peak Performance Under Pressure. If you're in the area, this conference runs from November 14th through the 15th. Link in the show notes with all the information. If you can't attend, I will be giving a report on a future podcast episode. But now, on to the news. Dateline Psychology of Sport and Exercise, April 2016. As I discussed several times on the podcast now, when, how frequently, and what type of feedback an athlete is given can have a dramatic effect on their performance. One of the things that is really lacking in this area are naturalistic studies which look at how feedback is actually being used during training and competition. This limitation was recently addressed in a really interesting study of boxing by Israel Halperin and colleagues from the Australian Institute of Sport. In this study, the in situ feedback given between rounds by 12 boxing coaches during the 2015 Australian Boxing Championships was recorded and analyzed. This is a really nice addition to studies looking at how coaches use feedback. For example, the gymnastics study I talked about back in episode 25C. In previous research, typically post hoc questionnaires have been used. In their study, Halperin and colleagues analyzed the feedback statements they recorded in terms of three factors that have been shown to be influential on performance. The first was attentional focus. Were the coach's comments indicative of an internal, external, or neutral focus of attention? For a discussion of the importance of this issue, please see episode 7. The second factor was autonomy support. That is, whether the coach promoted autonomy in the athlete, was controlling, or was neutral. The final factor was feedback valence. Were the comments positive, negative, or neutral? The proportion of statements that fell into each of these categories was calculated overall and separated for bouts in which the boxers won and lost. In total, 445 feedback statements from 25 bouts were analyzed. That's a lot of punchy comments. What was found? First, let's look at some examples from the different categories. Examples of internal focus of attention feedback were keep your hands up and keep your front foot on the outside. Conversely, examples of external focus of attention instructions included aim your hooks to his body and after the right to the body, end with a lead hook over her arms. Examples of autonomy supportive and controlling feedback were respectively try to drive that straight right through the guard if you can, and listen, move and jab, use a second attack if it's there. Finally, an example of positive feedback was you're looking good, looking sharp, while negative feedback was one thing you're doing wrong is you are throwing your lead punches and then you're falling in. So now to the key results. How much did coaches use each type of feedback and how did it differ for winning versus losing bouts? Before going into this, I'll point out that there was only one statistically significant effect that was found. Perhaps not surprisingly, coaches delivered significantly more positive feedback statements, 36%, in winning bouts compared to losing bouts, for which the percentage was only 18. Personally, I don't see the lack of statistical significance for the other variables being a huge problem for this study. Because remember, this is in situ field research, in which the experimenters had no control over what the coaches were saying. So what else was found? In winning bouts, coaches gave less internal feedback as compared to losing bouts, with the percentage dropping from 19 to 12%. It was also found that in winning bouts, coaches gave 10% less controlling feedback as compared to losing bouts. I think this is a really interesting study of feedback use in the wild, so to speak, and it's really nice to see the trends agree with a lot of the basic findings from laboratory research on motor control.
'Cause I'm bad news. Said I'm bad news, yeah. Said I'm bad news. Said I'm bad news, yeah. I don't know if I'm gonna stay with you.
Dateline, Experimental Brain Research, April 2016. Way back in episode 6, I discussed the idea of embodied perception. That is, the idea that we perceive the world not just in terms of basic physical quantities, like distances in meters and speeds in miles per hour, but rather our perception is also related to our action capabilities. Typical effects of this type we see in sports include batters on a hot streak perceiving the ball to be larger, and great basketball point guards saying that things seem to move in slow motion for them. In typical research in this area, which I discussed in detail in episode 6, either the inherent or momentary action capabilities of a participant are manipulated, and their perception of the environment is measured in some way. Inherent capabilities, of course, refer to more permanent things we would typically call skill or expertise level, while momentary capabilities refer to a specific play or action and can depend on temporary factors like level of fatigue and environmental conditions. While both of these things have been studied, previous research has not really examined how our momentary and inherent action capabilities interact. Enter Kandula and colleagues. In their study, a virtual reality setup was used with the Oculus Rift head-up display. Participants had to try and stop a virtual ball. On some trials, the virtual approaching ball disappeared, and participants were asked to estimate how far away it was when they last saw it. So in other words, response trials, in which participants had to stop the ball, were interleaved with estimation trials, in which they only judged its distance. This is a similar procedure to what I used in my baseball batting study in 2013. In the Kandula and colleagues study, inherent action capabilities were manipulated by comparing two groups of participants: regular video game players, that is, people who play more than 3 hours per week, and non-video game players. There were a total of 13 gamers and 12 non-gamers in the study. Momentary action capability was manipulated by changing the response required of the participant. On easy trials, the virtual ball could be stopped by pressing the spacebar once, while on difficult trials, it had to be pressed 5 times. What was found in this study? First, let's look at the ability of participants to estimate the distance of the virtual ball when it disappeared. In other words, consider only the trials in which the participants didn't actually make the stopping response. On easy trials, both the gamers and non-gamers could do this accurately, with errors that were not significantly different from zero. However, on the difficult trials, non-gamers made significant errors, with the ball being perceived as closer to them than it really was. Gamers continued to have estimation errors that were not significantly different from zero. Remember, on these estimation trials using the analysis, the conditions were actually exactly the same. The ball always just disappeared without them making a response. The effects are occurring because these trials are interleaved and with trials in which they are required to perform either an easy or difficult action. In terms of the actual stopping response, there was only one main effect. Not surprisingly, the gamers had faster response times than the non-gamers. What should we make of this study? For me, it's not really that exciting. The main result is essentially an experimental version of the saying, when the going get tough, the tough get going. That is, you're only likely to see big differences between experts and novices, in other words, differences due to inherent action capabilities, when you make the conditions really difficult. That is, you change the momentary action capabilities. For me, this is a basic effect that has been shown in a lot of previous research. I'm also not a big fan of the design of the task itself. It's kind of typical of a lot of perception action research, where we spend a lot of time and money generating a complex perceptual stimulus, then reduce the action to a button, or in this case a spacebar press. I personally think it's time to move on from these paradigms and use more realistic actions. A couple other issues. The task difficulty manipulation, pressing the spacebar 5 times versus only once, confounds difficulty with the time required to complete the response. And using a distance localization task leaves open several possibilities for explaining the main effect. Maybe gamers have better vergence eye movements than non-gamers, or focus their attention better. Or is it truly a perceptual effect where less skilled non-gamers see an object as closer so that they will start the response earlier? Well, that's it for the news. Coming soon on the Perception and Action podcast, why exactly do we have 2 eyes? What is the importance of stereo vision from controlling our actions? Remember, you can find everything you ever wanted to know about this podcast at perceptionaction.com. Also, if you're interested in articles like the ones I reviewed today, follow me on Twitter @ShakyWeights, where I post links to many more like this. This is your intrepid reporter Rob Gray from ASU, and I am out of here.